Let's start with a simple question. Does space have a smell or not? Logically speaking, space is a vacuum. There's no air out there. And without air, smell simply isn't possible. But then something strange happens. When astronauts return from a spacewalk, they say their suits smell like burnt metal, gunpowder, or even welding fumes. And that's where the confusion begins. If space doesn't have a smell, then where is this smell coming from? That's exactly what we're going to understand in this video, the science behind this smell of space, and what astronauts are actually smelling. Because if space is a vacuum, then logically, smell shouldn't exist there at all. In this video, we're going to calmly break down both possibilities. Let's clear one thing up first. When we talk about this smell of a planet, we don't mean that you could actually fly up to it and smell it with your nose. What smell means here is this. What kind of gases make up that planet's atmosphere? And if we could smell those gases in Earth-like air, what would they feel like to us? Let's understand this with a few examples. Mars. Mars's atmosphere is mostly carbon dioxide, and its surface is covered in iron oxide, basically rust. So according to scientists, if smelling Mars were possible, it would probably smell like rust, metal, and maybe a hint of sulfur. Now let's move to Venus. Venus's atmosphere is filled with clouds of sulfuric acid. In simple terms, imagine a smell like rotten eggs. Very unpleasant. Next, Jupiter. Jupiter is a gas giant, and its atmosphere contains ammonia and sulfur compounds. If you could smell it, it would be something like cleaning chemicals or bleach. And here's an interesting one, Titan, Saturn's moon. Titan's atmosphere contains hydrocarbons, which are very similar to the molecules found in gasoline. That's why scientists believe Titan might smell like petrol or fuel. So planets aren't boring at all. Each planet has a different atmosphere. And because of that, each one has its own unique idea of a smell. But now another interesting question comes up. Planets are still solid or gaseous bodies. But what about things like nebulae? How can they have a smell at all when they're made of nothing but gas and dust? Alright, now let's move beyond planets and talk about nebulae. First, let's clear up a common misconception. When we say nebula, it's not a cloud you could reach out and touch. A nebula is a region of space filled with gas and dust. The difference is that gas is spread out so thin that even if you were standing inside a nebula, it would feel like there's nothing there at all. Now here's a basic question. How does smell even work? Smell happens when molecules travel through air and reach your nose. Nebulae do contain molecules, but there's no air, and the density of those molecules is so incredibly low that smelling anything is practically impossible. So then how do scientists talk about the smell of nebulae? They're not describing an actual smell. They're describing chemical composition. In other words, what molecules exist inside a nebula, and if those same molecules were present on Earth, what would they smell like? Let's understand this with examples. The most common element in nebulae is hydrogen. Hydrogen has no smell at all, which means many nebulae could technically be completely odorless. But hydrogen isn't alone. Nebulae also contain ammonia, and on Earth, ammonia has a very strong smell, like cleaning products or bathroom chemicals. So when scientists say some nebulae might have a sharp smell, ammonia is the reason. Now let's talk about sulfur compounds. These are especially interesting. Sulfur molecules often form after stars die. When a star explodes, the leftover gas can contain sulfur compounds. On Earth, sulfur smells like rotten eggs. So if we imagine the smell of some nebulae, in many cases, it wouldn't be very pleasant. But the story doesn't end there. Nebulae also contain some surprisingly complex molecules, carbon-based molecules. In scientific terms, they're called polycyclic aromatic hydrocarbons, or PAHs. You don't need to remember the name. What matters is this. These are the same kinds of molecules found in smoke, burning wood, and fuel. Alright, Now let's talk about black holes. And first, let's clear up one thing. A black hole itself has no smell. Because a black hole isn't a solid object. It doesn't have an atmosphere where molecules float around. A black hole is a region of space where gravity is so intense that not even light can escape. So does the phrase "the smell of a black hole" make no sense? Not completely, because when scientists talk about it, they're actually referring to the region around a black hole. The gas, dust, and matter nearby, and the chemistry happening there. This brings us to an important concept, the accretion disk. When gas or dust approaches a black hole, it doesn't fall straight in. Instead, it starts spinning, forming a glowing, spiral-shaped disk. And this disk is where things get extreme. Temperatures rise to millions of degrees. Radiation floods the region. Normal chemistry completely breaks down. Molecules shatter. Atoms become ionized. Yet, gases are still present. Hydrogen, helium, and heavier elements pulled from nearby stars. On Earth, hydrogen and helium have no smell, which means technically, this environment could be smellless. But the story doesn't end there. Around some black holes, scientists have detected traces of sulfur and ammonia, leftovers from stars that once existed and were later torn apart. On Earth, sulfur smells like rotten eggs. Ammonia has a sharp, chemical odor. So if smelling were possible, the region around a black hole would be extremely unpleasant. But here's the catch. Radiation near a black hole is so powerful that stable molecules can't survive. And without stable molecules, smell itself becomes impossible. In other words, chemistry gets destroyed before a smell can even form. That's why the most accurate answer to "what does a black hole smell like?" is simply this: you'd never get the chance to smell anything. Some black holes also launch powerful jets of matter, traveling close to the speed of light, throwing ionized gas deep into space. If we use an Earth analogy, this might resemble the smell of ozone or burning electrical equipment. But again, that's just a comparison. No real smell exists. So in short, a black hole has no smell, and the space around it is too extreme, too unstable, and far beyond the limits of what smell even means. And now, think about this. If the concept of smell breaks down near black holes, what must it have been like during the Big Bang, when the entire universe was compressed into a single point? Now we have reached the last and most difficult part, the Big Bang. First, let's remove one wrong idea. The Big Bang was not an explosion that happened in the middle of space. The Big Bang meant that space itself expanded. Now that this is clear, we can talk about smell. Smell is possible only when three things exist: molecules, a medium, like air, and an observer. At the time of the Big Bang, out of these three, not even one properly existed. The universe was so extremely hot that even atoms were not stable. Molecules aren't even worth talking about. There were only particles, quarks, electrons, photons. Now in simple language, when something has a smell, its molecules are intact. At the time of the Big Bang, the temperature was trillions of degrees. At this temperature, no chemical bond can survive, which means the question of smell doesn't even come up. But still, people ask, if we imagine it, what would the Big Bang smell like? The answer to this is not direct. Scientists here don't talk about smell, they talk about energy and radiation. After the Big Bang, the universe cooled down a little. Then protons and neutrons formed. Then electrons appeared. And then, much later, the first atoms formed, hydrogen and helium. Now understand one important thing. By the time atoms formed, the universe had already expanded a lot. And even then, smell was not possible. Because for smell, not just atoms, molecules are needed. Molecules formed millions of years later, when the first stars formed and heavy elements were created inside them. So technically, the Big Bang could not have had any smell. But there is one interesting comparison that scientists sometimes use. When the universe was in its early stage, it was filled with radiation. If we use an Earth analogy, that environment would be like extreme heat, plasma, and electrical discharge. Meaning, if you try to imagine smell, it wouldn't be a smell, but an experience of heat and energy. One more important thing. After the Big Bang, the universe was not uniform. Conditions were not the same everywhere, but the concept of smell was not valid anywhere. Because smell requires stable chemistry, and that simply did not exist at that time. So when someone says, "What did the Big Bang smell like?" the scientific answer is, the Big Bang had no such thing as smell. Smell came later, when stars formed, planets formed, and chemistry became possible. And understanding this is important, because it makes one thing clear. Smell feels like a basic thing, but actually, it is a sign that the universe has matured. If we explain the entire video in one line, then the idea of the smell of space never meant that you could actually go into space and smell something. Smell is always connected to chemistry, and in space, chemistry is only possible when molecules exist, and the conditions for them are stable. In the case of planets, we saw that their smell depends on the gases in their atmosphere. In nebulae, the idea of smell comes up because many different molecules exist there, but they are spread out so much that smell is not actually possible in real life. In the case of black holes, smell is not related to the inside of the black hole, but to the extreme environment around it. And at the time of the Big Bang, the concept of smell did not exist at all, because there were neither atoms nor molecules. This means that smell is not a starting property of the universe. It is a late-stage feature. First, the universe had only energy. Then atoms formed. Then molecules formed. And only after that did conditions appear, where a sense like smell could become meaningful. So when we say the smell of space, we are actually trying to understand space in human terms. In reality, space is silent, cold, and mostly empty. But chemically, it is not completely dead. Reactions are happening there. Molecules are forming. And that same chemistry later becomes the foundation for stars, planets, and life. If this video helped you understand space in a slightly more realistic way, then AstroScience has done its job. For more topics like this, subscribe to the channel and share the video. Because space may feel mysterious, but it is just as logical. It simply needs to be understood the right way.